we talk about a database. So practically everything that we do uses some database. We know that it's evil because it's some way a side effect, but forget about this now. It's last talk, so make it a little bit easier. So we know kind of two ways. So there's the SQL and the NoSQL way, yeah? And so SQL is kind of stable and good and traditional. It is relational, it's transactional, yeah? And boring, of course, yeah? And then you have the NoSQL that is cool. It's somehow unreliable, so don't use it if you have data that you need, but for fun data, it's good, yeah? And for big data, of course, there's no transactions, it's not safe, and not relational. So, yeah, it's kind of the world. So let's see if it's really like that. I have my doubts about it. So let's see. One thing is relational databases are commonly used with something like Java and Hibernate, and that does some magic caching. So I doubt the transactions a little bit. So just think about it if it's really transactional or if you are destroying the transactions somehow in the way between. Then there is something like data warehouse, where it's really the big, the old style big data. And that's often relational SQL databases, but they don't really need transactions because they have like shut the whole thing down and then they put in some terabytes of data exclusively, and then they run it and they can run all kind of weird queries. So that's also SQL, but it's not necessarily transactional. And some non-SQL databases are actually 100% ACID transactional. So it's possible that combination. For example, Neo4j has a totally different data model, but it does transactions as PostgreSQL or Oracle. So the other thing is, no matter how uncool, SQL is very powerful, and you can do a lot of things with it. And I have some trouble doing the same level of things with anything else. But yeah, sometimes you can, of course. Then the other thing is we have an advantage in some NoSQL databases because they have less transactionality, let's put it this way, and then it's very easy to do things like replications. And in terms of transactions, it's extremely hard and limits us. That's kind of the thing. So I think it's the right tool. So for example, if we store money amounts, like how much money people paid or so, why not use the transactional SQL database? I think it's a decent way, it fits there. We have like transactions, money is paid or not, and makes sense. Then we have like sometimes data that can be structured very well with the relational model. So it's just like that, so we can just use it. We don't need to necessarily go somewhere else. Then we have the case that data is too big. Everybody is important, so our data is big and important and whatever, and of course Oracle isn't big enough. So we go for Mongo or for whatever you like. And I think it's a decent question, of course, but I think it's a good idea when you say the data is too big, get a decent DBA. There's really good DBAs, look at the data model, look how you set up the database, and you can actually do a lot with that. So maybe that's also an option. Or get a good software architect to think how your software works and make these things work. And so, yeah, it's possible to consider that way too. So the other thing is we have data that is not relational. Sometimes we do have that, yeah? So it's very hard to put it there, so why not use some tool that allows it? And sometimes we can even address this. So for example, PostgreSQL has a lot of extensions where we can put in data that is actually not typical relational data. Other databases have that too. I just know this one a bit better. So the other thing is we need like clustering or replication. And yeah, I mean, you do MongoDB, you do Cassandra, and you can do like cluster distributed and the data flows between the nodes, and if everything goes well, it's kind of nice. Then if connections crash and servers crash and too many, then of course you might end up in a mess that's very hard to clean up. But in the end of the day, it's much easier, and it's kind of the normal way to do. And if you want Oracle or PostgreSQL clustered and then maybe different locations, then you really need hardcore DBAs, not for half a day, but for really big money. Yeah. So I think that's a plus. Now, if you anyway like relational, so I think it's a question, probably you have bosses that tell you what to use either way, but maybe you are the bosses or you people who can ask, and it's my personal opinion, so not more. But I think like PostgreSQL is a bit better. It's a bit easier, a bit closer to the standard, and it's a little bit easier to maintain, and it's free. So, but then on the other thing, Oracle is more enterprise. If you have like money and you want somebody to be the vacuum cleaner that collects your money, I mean, Oracle is very good for that. And it has really serious good features for high availability. So if you have like clustered database and you put the bomb into one, then the Oracle will be there maybe some seconds, and PostgreSQL maybe 10 minutes later, if your DBAs did really good job. But that's, yeah, they have some point there, they are much better with this. And it is a good database. So if you have it, I think it has some things that are a little bit rough, but you can work with it. It's quite okay. So the point is all SQL databases are different. So you should kind of pick one and live with it. And it's very hard to support multiple SQL databases because in the end you need to support special features. And the best thing is you test with this H2 and then you run with Oracle, and then you get all kind of bugs that only occur in production because the test was totally different setup. But yeah, so I think it's the wrong way to go, and you can tune your SQL database for development. You can run it in memory, you can skip the D of ACID, and then it runs twice as fast, and there's things to do. So for the NoSQL, it's even more different. Yeah, so it's just everything that is not in this family is that's Datomic, it's Cassandra, and they are totally different. So you really have to think exactly what is the one or the two that matches your course. And you can, for example, Cassandra has really fantastic write performance. Yeah, it's distributed, it just works, and replication and these things, but it needs more disk space. It's just the way it is that you need for the same kind of data more disk space. So it's cheap, but for big data it's maybe not so cheap. Has this eventual consistency, not transactional. And then when you test, you have kind of to worry about what you just wrote is not there when you test it. So it's something you need to deal with. They have a query language that's kind of SQL, but not quite. And it is very limited in terms of queries. So with SQL you can join and query with any condition and you get kind of what you want, and this one is really not like that. So you have to put your data in such a way that whatever you query is already there in a way easily to query. So that's that. But for analyzing data, you can copy it to Oracle or PostgreSQL and then do analysis of your data there and reason about the data for if you need that. So MongoDB, that's a totally different story. It is ACID transactional if you want to run it, but it only puts one operation in a transaction. So you have to kind of structure your data that your transactions live in one table, and that's it, and one document. It's called like that. But then on the other hand, you can use JavaScript as a query language. You can hate it or like it or whatever, but that's what they give you. And it is powerful. You can query, and you have complicated queries. Data is kind of JSON, not quite, but almost. And yeah, it is very powerful for querying indexing if you live by their world and adapt to how they work. So That's the point. You should understand your problem and understand the tool set and look what's cool, okay, but look what's useful, and try to get the best that you can that your bosses allow you to use. So that's what is, and as I said, you have maybe a tool or a toolbox. Maybe it's good to have 2 different databases or 3 different for what you do. And I think databases are very cool, even though we have to think it's not side effect free, but it's a cool thing. And if you use them with Scala, it's very cool. Okay, thank you very much. Any questions? Or do we have time for questions at all? Yeah. Okay. Yes, please. I haven't heard it. Yes, yes. It is. I think it is a database. It's just combined with a tool, so you have kind of a very powerful query language for a certain purpose. Yeah, I would say, and it's very fast. So it's a good database, but for one very specific purpose. Yes, please.
Have you used some graph databases like OrientDB or ArangoDB?
I have not, no. I have dealt a little with Neo4j, but below using it. And I think it's powerful, but it's a question if the query language is as mature as SQL. So I think you have to fight that issue a bit, is my feeling. Okay. Yeah, thank you very much.